Hi, and lastly, welcome to the MAED Hands-on 10 exercise, the final video and exercise of this course. So by the end of this, we are going to know how to review results and case studies in MAED. What we're going to do is check base year and future years results, adjust scenario assumptions to match base year results with hourly demand data, add projected years to the model, and explore the effect of changing scenario assumptions on hourly demand. So to start off with, what we're going to do is we're going to be reviewing base year results. As stated, we will have a brief introduction into how to resolve the results. This activity uses the MAED mode case study that we used in the previous hands-on. After the last session, all scenario data have been defined, so the next step is to check the base year data. As we have seen in the previous hands-on, you can review the results after calculating them by clicking on the results tab and navigating on the menu. So what we're going to do is we're going to come over here, click on results. Well, firstly click on calculate again, and then we're going to stay on the summary page. To check the results of the base year, then compare the maximum load values with the statistical data. The maximum load in each season predicted in MAED should match the statistical data within an acceptable margin. You should also check that the season in which the peak load occurs matches the base year data. Similarly, you should evaluate whether the load factors in each season are consistent with the base year values. So, over here we can see that the maximum load data, we can see the relation to peak annual, and we can see the load factor. So let's see if these numbers correspond. Yes, these numbers appear to be corresponding. And essentially what we want to do over here within the results is firstly check the maximum load in each season predicted in the MAED should match the statistical data within an acceptable margin. So over here the maximum load is the numbers that have been defined over here, and what we need to do is check that it should match the statistical data that there is present outside of the model within an acceptable margin. We should also check the season in which the peak load occurs and see that if this matches the base year results. So if we go back over here, we can see that the peak load occurs in the summer, and let's say for example if we go into the chart, here we can see the LBC. Let's change this to the load curve. And we can see that in fact the summer period is the period over here. We can see that this is where the maximum load is covered. We should also check that the season in which similarly, we should evaluate whether the load factors in each season are consistent within the base year, and this is down outside of the model, so we're going to look at these results and the numbers that we've input, and we need to check that they're similar. So if the base year results are satisfactory, we can analyze the results for the other years of the study to check the consistency with expectation and other projections. Otherwise, we need to review the input data and repeat the process until the MAED results match your base year data with an acceptable margin of error. The scenario assumptions that most commonly lead to mismatch between the reference year and the results are annual demand, percentage of electricity supplied by the grid, clients, transmission and distribution losses, and seasonal daily and hourly coefficients. So make sure that you check this data over and over until the data that you have match that of your MAED model with an acceptable margin of error. What we're going to do is now we're going to add years to the case study. So we're going to assume that the base year is correct. What we want to do is now add the years 2044 and 2050 to the study. So we come over here, we go into the general info, over here we put a comma, 2044 and 2050, and we click on save. Now we've added the respective years. Next we want to click on the electricity tab under the general information, heading to the navigation menu on the left side. So we're going to click on electricity. Then the next thing we want to do is click on annual electricity demand. which is already the one that's been clicked. We assume that each sector has an equal annual electricity demand in each year, which is 10,000 gigawatt hours in 2038. And what we want to do is input 12,000 for 2044 and 15,000 for 2050. So we're going to come over here, 12,000. Let's Control C, Control V, Control V, Control V, and 15,000. Control C, Control V, Control V, Control V. And we click on Save Data. Now this data has been saved. Now we click on the electricity supplied from the grid. We assume that all sectors get 100% of the electricity from the grid in every year, so we input 100 for all of the numbers. So we go back over here and we put 100 in all of the numbers. Click on Save. We go to Electricity Demand per Client tab at the top of the page. We assume that every sector is composed of a single client and there is 100% for each client. So similar to over here. So we're going to go Electricity Demand per Client, and we're going to copy this, paste, 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 and we click on Save. Lastly, we're going to go to the distribution and losses. So we should input 5% for the transmission losses and 10% for distribution losses in each of the years. So we're going to put 5, 5, and then we're going to put 10, 10. Save data. Now we want to go into the industry tab under the coefficients. We select the weekly coefficients tab at the top of the page, which is the one that's already been selected. So we assume that the base year modulating coefficients can be used to model our demand projected years for the projected years. So we should just copy the weekly coefficients from this year onto the next ones. And then we repeat the same for the daily and hourly coefficients. So I'm going to copy this. And we're going to click on Save. What we're going to do is we're going to copy all of this. And we're going to click on Save. So now we've already defined also the daily coefficients. Let's check to see if this has saved. This has. And the last thing remaining to do is the hourly coefficients. So we copy this data. Click on Save. Click on Save. There we go. Now we've copied all the information over from all the other tabs. There's a tiny bit of discrepancy over here, with some of the values being a bit over and above, but that's alright. So once we've done this, we click on the Calculate type. Calculate. And now we have the different results for the different years. So we can look at all of the years over here. So we have the 2044, 2050, and 2038. There's a difference in the some of the maximum load and some of the years, the data that the results that have been calculated. So we should check that the maximum load in each season and the season in which the maximum load occurs and the load factor in each season. So if we go over here, we check the maximum load in each season. The highest over here is autumn and the highest over here is spring. So there's a there's autumn again, so there's a difference between that of the base year, and that means that somewhere in the copying and pasting of numbers something was done incorrectly. We can check the load factor, and we can see that the highest load factor is in winter, whereas in the base year the highest load factor was in spring. So that means again that in copying and pasting something was done incorrectly with the numbers. So because these results are for future and are no statistical data to compare to, you should rely on those with experience to assess the validity of results. You can also compare the MAED projections with the results from other models. So we can see that there's the numbers over here like this. However, the numbers that I've obtained do not match these, they're smaller. So what we need to do is go back and check and understand where did I go wrong. So if we come into electricity, we see that the numbers appear to be correct. Electricity supplied from the grid, yep. On calendar we made no changes, so that is also fine. On the coefficients for industry, numbers were copied and pasted in the same way. What I did is I missed the step where it says that we had to copy and paste the numbers for the daily, hourly, and weekly coefficients for all the other sectors. So what I'm gonna do is I'm gonna repeat this. I'm going to copy and paste these numbers for all the other sectors. And I can see that the results now are different and they correspond to the ones over here, so that looks to be all correct. So in order to check the results again, we can just skim over them and see whether they match in terms of the maximum load. They do. The highest maximum load is in summer. In terms of the load factor, the highest load factor appears to be in spring, so the results seem to be fine. What we can do now is we can go and visualize the chart of the results. And here we can see that the hourly demand rises from 2038 and 2044, and again from 44 to 4050, as we might expect, because we increase the total annual electricity demand. The weekly and seasonal patterns of the demand do not change because we keep the same modality of the coefficients. Now let's say we want to develop an alternate scenario to understand the impact of improvements in the transmission and distribution system. New power lines will be built and accuracy in metering will be improved. These measures will reduce the transmission and distribution losses respectively. The transmission losses at the end of the study period will be 3%, while the distribution losses will be 5%. So first we want to go into the managed case study on the top of the screen. We find a case study named MAED and we'll make a copy of this. So we come over here, manage case studies, make a copy, and we click on that. We're gonna rename this to TD improvement. So let's copy this, TD improvement, and we're gonna rename this to TD improvement. We click on save. Now this has been renamed to TD improvement. Once we've change the name of this, what we want to do is go and change the values for transmission and distribution. So we come over here, we're going to electricity, we go into transmission and distribution, and over here we're going to change the numbers to 5, 4, 3 respectively for transmission, 10, 8, 5 respectively for distribution. So 4, 3, 8, 5. Click on save. Click on save once more just in case. So now we've changed this, and we want to click on the calculate button to see what the impact of this would be. So we can see that the energy generation compared to the previous data that we had is much lower. This is because what's happened is that there is less losses being happening from the transmission and distribution network. Therefore, less energy needs to be generated in order to compensate for the demand that's been defined in the model. You can check the results once more just to see what this is the case. And this is how you would do scenario analysis using the MAED model. You can build different scenarios, and ideally you want to do the same thing. So you want to copy and paste the case studies and then change different factors with it to see how this ends up looking in the end. Thank you very much for watching this video, and I hope this was useful to you.